Good morning, students. This is the solution video for the MJ 2019 paper 2-2. As usual, please refer to the timestamps available in the description below for specific questions, and please pause the down the working as I'll be showing the solution to the question continuously. Without further ado, let's begin. So we start off with the first few questions, starting from number 1. We have write down a prime number between 51 and 60. So usually prime numbers are odd. So if you're not sure what prime numbers they are, just list them all down first. We have 51, 53, 55, 57, and 59. Right. 55 is always out of the picture because any number that ends with 5 can be divided by 5. Right. So we don't care about that. Now our concern is the rest here. Now 51 and 57 are quite special cases because these two numbers can divide by 3 specifically. So if you want to check whether the number can be divided, I recommend you just try to divide with the odd number because odd numbers can divide odd numbers. Sorry. So from here, 51 divided by 3 can be done. So this is not a prime number, and this one also is not a prime number. So your answer is either 53 or 59. So you can just write out one of them, right? Either one is fine. So from here, number 2, we have calculator work again, 1 minus sine 3, holding the power of 2. But take note that this sine 33 applies, this square applies to the sine 33 only. So when you write in your calculator, I recommend you to write it like this, right? To avoid any confusion. So you should write it like this. So it will be square root of 1 minus sine 33 square. So that would be 0.839, correct the 3 in even figures. So to write the recurring 0.7 as a fraction. So again, we have let x equals to 0.777. And then we multiply both sides by 10. So that'll be 7.777. So we can call this 1, call this 2. So equation 2 minus equation 1. So that would be 9x equals to 7. X equals to 7 over 9. If you already knew this, you can just write the answer because this question has only 1 mark. So there's no working required for this case. So for number 4, A, a quadrilateral with only one pair of parallel sides is called a trapezium, right? So only trapeziums can have this. The rest usually have 2 sets, right? With the exception of the kite. The kite doesn't have any parallel sides at all. So for number B, we have an angle is greater than 90 degrees, but less than 180 degrees is an obtuse angle. So this one is just memorizing the name. If you don't remember the name, I recommend you guys to study a little bit more. That would help. So for number 5, I'll just take another screenshot because this, in case I miss out any words at the bottom. So from here, the distance between Prague and Vienna is 254 kilometers. The local time in Prague is the same time as the local time in Vienna, so we don't have to be concerned with the time change. So a train leaves Prague at 3:30 p.m. and arrives in Vienna at 7:50 p.m. or 19:50 lah. So this is a 24-hour system. So think that 15:20 is afternoon already. So that means it's 3:20 in the afternoon, evening, and 19:50 will be 7:50 p.m. or that would be around nighttime already, right? So from here, we will have they ask us to calculate the average speed of the train. So in this case, we have average speed would be equals to the total distance over the total time, right? So all we need to do is just find out what those are. So we are given the distance already, 254 kilometers. Now we need the total time. So from 3:20 p.m. to 7:50 p.m., without much calculation, we can tell that it takes 4 hours and 30 minutes. Now you have to be careful because the speed is in kilometer per hour. So you can't write it like this. We need to change it to hours. So it is actually 4 hours and 30 over 6. 430 over 60 hours in this case. Because 1 hour is 60 minutes, which will simplify to 4 1 over 2 hours. And in decimal, it will be 4.5 hours. So we'll be using this. So from here will be 254 divided by 4.5. So 254 divided by 4.5 will give us 56.4 kilometers per hour, correct to 3 decimal places, 3 in figures. So that's for question number 5. So for question number 6, and I'm able to take 7 as well, so I'm going to take both. So for number 6 would be 9f plus 11 equals to 3f plus 23. So from here, it's a simple linear solve. So we are going to all the unknowns to the left side, minus 3f on both sides. So we have 6f plus 11 equals to 23. And then we minus 11 on both sides. So minus 11 here, minus 11 here. So that would be 6f equals to 12. And then finally, we divide 6 on both sides. So our answer would be f equals to 2, right? And that's for number 6 done. So moving on to question number 7. So for question number 7, it is the area of triangles. So they've given us the height, they've given us the base. All we need to do is just take half multiplied by the height and the base, or the base and the height. Either order is fine, doesn't really matter. So we will get 1 over 2, 3.5, 8.4. That is 14.7 cm square. That one is done. So from here, we have question numbers 8, 9, and 10. Just gonna pull it up here real quick. So we have question number 8 first. So write this number correct, two significant figures. So the 2 zeros in the front doesn't count. So we start counting starting from number 4. So number 4 is one significant figure. Number 7 is one significant figure. So the answer is 0.048. Correct to two significant figures. So for the next part B, write this number in standard form. So this is a small number. So it's gonna if we move the decimal place to a number right at the 5 mark. So it's 1, 2, and 3. We move the decimal places 3 times. So it will be 5.27 times 10 to the power of -3. Why -3? Because it is a small number. It is a large number. We call it power 3 by itself. Right. So number 9, find the highest common factor of 90 and 48. So we draw the L to help us here. We keep dividing the numbers until they can't divide any further. So it's 45 and 24. These two numbers still can divide by 3. So that's 15 and 8, and then we stop here. So ultimately speaking, your HCF is the numbers multiplied here. So HCF would simply be 2 multiplied by 3, which is 6. So that's the highest common factor of 90 and 48. So number 10, so on a map with a scale 1 to 25,000, the area of a lake is 33.6 square centimeters. If your answer, calculate the area of the lake, giving your answer in square kilometers, right? So this is on a map in square centimeters, yeah. So once again, this is a scale in cm. This is an area in cm square, right? So in other words, the length of the image over the length of the object ratio, if you want to work the ratio out, that is equals to the square root of the area of the image over the area of the object in this case. So when we look at the ratio, we obviously know that this is the map scale. So this is your image, this is your model. 25,000 is the real life, so we call this as the object, right? So when we plug in the values, this would be length of the image is just 1, and then length of the real life is 25,000. So square root of, so the area of the image is 33.6 square centimeters. I shouldn't be using this yet. I should convert it to, oh actually I know, I can use it first, sorry, because we change it to kilometers later. So A over AO. So from here, we want to solve for our AO. We will square both sides of the equation. So 1 over 25,000 square would be pretty big, will be a pretty big number. So that's about, our in standard form is 1.6 times 10 to the power 9, -9 equals to 33.6 over AO. So AO and 1.6 times 10 to the power -9 can swap places. So that would be something like this. And we can count out what this is. So this is the area of the lake is 2.1 times 10 to the power of 10 cm square. So now we need to change it to km square. So we can work with the basic conversion first. Cm to meter is divide 100, whereas meter to kilometer is divide 1,000. So in other words, to go from cm to km, we are dividing by 5 zeros. So in other words, 100,000, right? And not only that, if you're doing from cm square to km square, we are going to divide by 100,000 square. So converting this, we have to divide by 100,000 square. So 2.1 times 10 to the power of 10 divided by 100,000 square. So that would be 2.1 kilometers square. So that is the area of the lake in real life. So moving on to question number 11. 11, please skip because you are using this is a matrix question. This is part of the old syllables, no longer relevant to us. So we are looking at number 12 and 13. So for number 12 and 13, 12 simplify 5m squared times 2m cubed. So we're going to multiply the numbers first. 5 times 2 will give us 10. M squared times m cubed is m to the power of 2 plus 3. So that is just 10m power 5. Right. And then for B, it is x power 8 to the power of 3. Power on power is multiply, so x power of 24. So that's that. So for number 13, we have a fraction 2 1 over 4 divide 3 over 7. So we can just work slowly. They want the answer in mixed number. So it will be 2 1 over 4 divided by 3 over 7. I recommend changing to improper fraction first. So this is 9 over 4 divided by 3 over 7. After that, we change it to a multiplication. So 9 over 4 times 7 over 3. We will flip the right fraction when we change it from divide to times. So from here, we will get 63 over 12. And then when we simplify it a little bit further, both the top number and the bottom number can divide by 3. So this would be 21 over 4. And then finally, this would be 5 1 over 4. So that is simplified. So that's for number 13 done. And then we move on to number 14 and 15. So for 14 and 15, question given here is a simultaneous equation. You're free to use whatever method you want, but I always prefer to use the substitution method. And I always work with the easier looking equation. So the bottom equation is easier to work with. So this is just for me personally because the numbers are smaller. So first of all, I multiply all the terms by 2. So it will be x plus 6y equals to 14. And then I move the 6y to the other side. X equals 14 minus 6y. So we have this as equation 1. And we have the equation we didn't touch as equation 2. So I'm going to sub 1 into 2. So sub 1 into 2, this would be 5. 14 minus 6y plus 8y equals to 4. Then that would be 70 minus 30y plus 8y equals to 4. 70 minus 22y equals to 4. Both sides minus 70. Negative 22y equals to negative 66. Finally, y equals to 3. So from there, we sub it back into 1. And then x equals to 14 minus 6 times 3. So it'd be 14 minus 18, which is negative 4. So x is negative 4, y is 3. So that's for number 14 done. And then we move on to number 15. So 15, Shauna buys a chair in a sale for 43560. This is a 12% reduction on the original price. So that means the reduction has already been committed. So in other words, 12 from the 100%, we don't know what's the original price. 100% is the original price. So we know that the value dropped to 88% because it's a 12% off, right? So it's minus 12%. Oops. Minus 12%, it becomes 88%. So 88% is 435.6. So there are two approaches for this. You could find the 1% and then convert it to 100%. That's the first approach. So it means both sides you divide by 88. So 435.6 divide by 88. And then we multiply it by 100. So that's 1% is 4.95. So we multiply by 100, we get 100%. So 100% is $495 immediately. So this is one of the methods. The alternate method is if you can see, we can use the multiplier. So in this case, 435.6, we want to find the original. We are going to divide by 0.88, which is the value that it is at the moment here. So from here, this would be also 495. So it depends on what you do, but both methods will give you the full 3 marks. Right. So moving on to question 16. So for question number 16, we have kind of a sketch question. Oh, sorry. Right. So for the sketch question here, they have drawn the graphs for us already. By shading the unwanted regions and label the region R label the region R that satisfies the 3 inequalities. So we need to identify which line is which, right? So we can tell very easily because they all have different y-intercept. So just by observing the y-intercept, we are good to go already. So for the first two, the y-intercept is 6. So the y-intercept is 6 means it is this blue, the line that I'll label in blue here. This blue color line is the y equals to 12, 1 over 2x, negative 1 over 2x plus 6, right? So for the next line, I'm labeling green, negative 4 gradient, negative 4 y-intercept. So this is the line here. So this will be labeled as y equals to 3x minus 4. And finally, the last line, I don't need to even look at the equation because this is the only thing left. So it's just x plus y equals right? So we have our 3-line equations here. Now, they want us to shape the unwanted region. So in other words, we need to shape in the opposite direction that we need to go. So here, find for the first one, y is less than equals to -1 over 2x plus 6. So in other words, we are interested in the area below the line. So we need to shade the unwanted region. The unwanted region is above the line. So I shade here, right? So you don't have to color the whole thing. What I recommend is that you just do like this also good enough already. Just draw lines like that. Single straight lines with ruler is good enough, right? And then next one would be in green, y greater than equals to 3x minus 4. So greater than equals 3x minus 4 means it must be above the line. So the place that we don't want is below the line. So we're going to shade below. So we shade below here. Right? And then lastly, we have x plus y greater equals to 5 means we want the area above the line. So we need to shade the area below the line. So from here, we just shade below the line in yellow. So you notice that this one tiny space in the middle here, we can label this as R, right? And they ask us to find from here what is the largest value of x plus y, where x and y are integers. So we are looking at specific integer values of this internal portion here. So to get the value from here, all we need to do is just, what I normally recommend is first, you just select the vertices. With the vertices itself, you usually would be able to find the answer already, or it could be some other value else, so we can check first. So looking at this vertex value, this is 7, -2, oh sorry, -2, 7. And then another coordinate that looks fine is 0, 6. And then another coordinate here, this is a fractional coordinate, so we don't care. This is also fractional, we don't care. And then the last one, last two that needs attention is 0, 5, and this one here, which is 1, 4. Right. So we notice that there is not a lot to work with. And if you add everything together, because they said largest value of x plus y, so -2 plus 7 will give us 5, 0 plus 5 will give us 5, 1 plus 4 also give us 5. So the largest value is 0 plus 6, which is 6. So in other words, x plus y equals to 0 plus 6, which is 6. This is our largest integer value possible. So you can test every single value that makes sense in this question. So when we do that, we notice that it is not on the vertex, but it's just somewhere in the zone, right? So we just need to select a coordinate within the zone to help us to work, right? Actually, come to think of it, there's actually one more that I didn't realize. This is actually here. This coordinate there is 2, 5, I think. Yeah, that's larger. So 2 plus 5 equals to 7, right? So that's one more larger. I just missed it out. So carry on to the next question. So write as a single fraction in its simplest form. So we have 2x over x plus 3 plus x plus 3x minus 5. So from here, work with the denominators first. So we have 2x over x plus 3, whole thing multiply the whole numerator and denominator multiplied by x minus 5, we borrow. And as for the other side, we will multiply both sides by x minus 3. X plus 3, sorry. So from here, we have 2x squared minus 10x over x minus 5x plus 3 plus x plus 3 squared over x minus 5x plus 3. So we're going to combine these together. So this would be 2x squared minus 10x plus x squared plus 6x plus 9 over x minus 5 plus 3. So that would be 2x squared plus x squared is 3x squared, -10x plus 6x, -4x plus 9. So whole thing divided by x minus 5, x plus 3, and then we are done. There's no more simplification that can be done from here. Right, so this is finished because this is a simple. You can expand the bottom as well. If you don't expand, it is also like no problems there. Right. So we're going to question number 18. So question number 18 is frequency density problem. So they said they draw a histogram. The height of the bar for this particular class is 7. So before we even start counting first, the rest, we should try and see whether this actually matches. So the formula for the frequency density, it is the frequency over the class width. So for the case of 15 to 25, talking about this one first, so it is 35 over 10, which is 3.5. So the frequency density is 3.5. However, the height is 7 cm. In other words, all of the heights are scaled by 2. So when we calculate frequency density for the rest, we need to multiply it by 2 to get the exact height. So for the next one, so for the class of 25 to 30, so the frequency density is f over class width. So that is 32 over 5. So that would be 6.4. And then from there, the height would be 12.8 cm multiplied by 2. So for the next one, FD equals to 44 over 20. So that is 2.2. And then multiplied by 2 is 4.4 cm. And the last FD would be 12 divided by 30. So 12 divided by 30 would be 0.4 multiplied by 2 is 0.8. So these are our three answers respectively. So this is 12.8, 4.4, and 0.8. So that's done for all three. So for question number 19 and 20, so for number 19, it is a rearranging question. So for our rearrangement, all we need to do is just focus on our subject. So our subject is M. So we try to focus on putting M onto the same side. First, get rid of the fractions. So what I'm going to do first is that I'm going to multiply everything by, M. So both sides multiplied by M will be MP equals to K plus M. And I'm going to move all the M's to one side. So MP minus M equals to K. Factorize out the M. And then finally, divide the whole thing by P minus 1. So M equals to K, P minus P. So that's 4 marks done. So for number 20, solve the equation of 3x squared minus 2x minus 10 equals 0. And when they ask to give the answer correct to 2 decimal places, they usually will want you to show, they want to see you using quadratic formula. So we have A equals to 3, B equals to -2, and C equals to -10. So the quadratic formula is x equals to -b plus minus square root of b squared minus 4ac, whole thing divided by 2a. So there will be -2 plus minus square root of -2 squared minus 4 times 3 times -10, whole thing divided by 2a. 2 times 3, sorry. So that would be, let's scroll down a little bit. Oh dear. Can't scroll down. There we go. So then from here, we have 2 plus minus square root of 4 minus or 4 plus 120, whole thing divided by 6. So this will be 2 plus minus square root of 124 over 6. So from there, we can split into two answers. 2 plus square root 124 over 6, and then the other one is 2 minus square root of 124 over 6. And then from there, we can use our calculator, right? So that would be to do decimal place is 2.19, and then the second one would be -1.52. So those are our two answers to two decimal places. So that's for 20 done. And then for 21, it is a Venn diagram question. So for our Venn diagram question, we're just looking at, I think I should clear all of this first. So in the Venn diagram, shade x prime intersect y. So first we will just color out x prime. So x prime is just here. So we have x prime here. And we're going to intersect that with y. So we're taking the intersection point between x prime and y. So we're going to erase whatever that is not relevant. So we erase everything else that are not relevant here. Only the portions that y are kept. So x prime intersect y would just be that part within y here. right? This is our answer. So that's for part A done. So in part B, Venn diagram below shows information about the number of gardeners who grows melons, potatoes, and carrots. Gardener is chosen at random from the gardeners who grow melons. So take note of this situation. They are purposefully choosing someone from the melon farm. So your focus is this circle here to start. So from here, find the probability that this gardener does not grow carrot. So does not grow carrot means it's either this person or this person. In other words, it is probability of no carrot is 3 plus 6 divided by 3 plus 6 plus 5 plus 2, which is the total. So from here it's 9 over 16. So this is done. So that is for B1 complete. And then I think there was a B, yeah, there's a B2. So I'm just going to place it here. So for B2, find the number of M intersect P union C prime. So I'm going to get the Venn diagram again, so it's a little bit easier to see. So first of all, first part is M intersect P, yeah? So we're going to just do from left to right first. Look at M intersect P first. So M intersect P is just here, right? Quite simply. So I shouldn't shade too dark. Later I can't see the numbers, right? Now, when you union something, means you're going to combine it. So union C prime would simply be combining it with everything else in C prime. So how many regions are selected? So it will be 3, 6, 2, 12, and 23. So from here, it will be 3 plus 6 plus 2 plus 12 plus 23. So that would just be 46. And that is done. So remember, for intersect, it is you're erasing the shade. For union, you're combining the shade. So please don't forget about that. So for 22, we skip because it is a matrix question again. Whereas for 23, we can attempt it. So for 23, so we are given a parallelogram with AB as Q, AD as P. ABM is a straight line, where ABBM is 1 to 1. So that means this is Q, this is also Q, right? And then for ADN is also straight line. AD is 3, BN is 2. So AD is 3 parts, BN is 2 parts, right? So in totality, they have 5 parts. So if you want to create something for our DN here, what we can do is that usually I will just write it in a straight line like that, a little bit easier to see. So this is AD and N. So if AD is 3 parts, DN is 2 parts, and this is P, whole thing is 5. Huh? So I can write this in terms of AD. So I know that A to N is 5 out of 3 P, right? So in other words, we are just working out the fraction for AN, whereas for DN is simply AN minus AD. So it is 5 over 3P minus P. So this is 2 over 3P, right? So I know that DN is 2 over 3P here. So I can label this here as well. So this helps us to find our next question, which is MN partially. So for part A, we have MN, which can be broken down to become MA plus AN. So we have MA as negative Q or negative 2Q plus AN would just be 5 over 3P as I established earlier. So that's done for part A. So for part B, straight line NM cuts BC at X. X is the midpoint of MN. So this is middle, yeah? So this is 1 to 1. So from here we have Px equals to Kp. Find the value of K. So we can ratio it down. So we have bx equals to BA plus AN plus NX to work with. So BA is negative Q, AN is 5/3P, and NX is half of NM. So from here, we counted MN earlier, so we just need to change the symbols. So it will be half of positive 2Q minus 5/3P. So this is negative Q plus 5/3P plus Q minus 5/6P. So Q and Q cancel out. So 5/3 minus 5/6 would be will also be 5/6P. So therefore K equals to 5/6. So that's for question 23 done. So for our last question, not last question yet. So we are going to 24 first. So for question 24, we have A, B, C, D, E, F, G, H is a cuboid. AB is 18, BC is 7, CG is 12. So calculate the angle that the diagonal AG makes with the base ABCD. So if you notice, I can draw an additional line here from A to C, just to highlight out the triangle ACG like this. So I have a triangle. If I draw it out in 2D plane here, this is ACG. This is 12, and they're looking for this angle. So from here, we can find the base AC according to Pythagoras theorem from here. So we have AC equals to 18 square plus 7 square whole thing square root. So that would be square root of 373. I'll leave it insert first. So this is square root of 373. So immediately from here, I can use 10 because based on this angle's perspective, this is opposite and this is adjacent. So this is for POA. So tangent of GAC equals to opposite over adjacent. So that would be 12 over square root 373. And we can solve for GAC by doing shift 10. So shift 10, 12 over square root 373. So that's 31.9 degrees correctly, three significant figures. So for our last question, we are looking at 25 for transformations. So I will just pull this out. So from here, they ask us to work out the single transformation from A to B. So we can tell very evidently that going from A to B, they have actually perform a kind of rotation. Because from here, we notice that the orientation changed from A to B. So we straight away know our first answer would just be this is a rotation. So from here, we know that this rotation occurs at a 90 degree because see, this was flat straight. Now it's pointing to the left, right? This line was pointing straight. This triangle was pointing straight down. Now it pointed to the left. So it is a 90 degree and moving in the direction that I drew the arrow as well. So this is a 90 degree clockwise rotation, right? And lastly, we need to know where is the center. So to identify the center, because I know it rotated like this, so when I draw my center should make an angle like this. The 90 degree should be something like this. So the 90 degree is somewhere around here in this place. So we can try to eyeball it, but first we need to identify some points. So let's just take 2 points as perspective. This is the tip and this is the tip. Now, the answer is somewhere inside here. So from here, we can roughly take, let's say, origin, for instance, right? And we measure the distance from here to here, followed by here to here. You notice that the distances don't match, and you notice the angle also don't make 90 degree. So it means that, but it's pretty close. So it means that the center is somewhere nearby. So I could test maybe here instead, 0, 1, 0. So when I draw, the distance is 4 boxes, distance is also 4 boxes. And you notice I make a perfect 90-degree here. So my center is 1, 0. So I can write this all in a sentence form now for my description. So the transformation is a rotation 90 degrees clockwise about center 1, 0. And that's done. That is your 3 marks for your transformation. And then for your last one, triangle A to C. So triangle A to C also swap orientation. However, the bigger concern here is that it has transformed size. So if the size changes for your transformation, we are more interested in a different transformation known as enlargement. So for enlargement, first we need to find out what is the scale factor. So from here, our scale factor, if I take the height of the triangle, this height is 3, 6, 10 units tall, whereas this height here is 5 units tall. So we know our enlargement from A to C, the scale factor is 2, because scale factor is, or K, is image over object length. So the image is 10, the object is 5, so the scale factor is 2. Right? And lastly, where to find the center? We are gonna just connect it by lines. So this tip and this tip are the same. This corner and this corner is the same as well. So our center is somewhere around here. If you use your proper ruler, you get it precisely at this point. For now, it is a little bit off. So this is 0, 2. So from here, for our description, the transformation is an enlargement with scale factor. Sorry, one more thing about the scale factor also. If the orientation changes for the scale factor, this is a -2 scale factor at center 0, 2. Right. So that is all for this paper. So good luck for the rest of your preparation. I'll see you all soon.